This is Mrs. Benke. In this screencast, we will be looking at Boyle's law as well as pressure and volume conversions. Pressure is a force exerted by a substance per unit area on another substance. In chemistry, we talk about the pressure of a gas, which is the force that the gas exerts on the walls of its container. Standard pressure is 101.3 kilopascals, 1 atmosphere, 760 torr, and 760 millimeters of mercury. When we do these problems for gas laws, we need to make sure that our pressure units are the same. So let's take a look at how we do pressure conversions. Let's say in a problem we are given 105 kilopascals and we are asked to find how many torr that is. We have to use our standard pressures that are given in the box on the left of your screen. We start by taking our given unit, 105 kilopascals, and we place it over 1. I want kilopascals to cancel out, so I'm going to look at my chart and I see that for kilopascals my value is 101.3. So on the bottom of my next fraction I write 101.3 kPa. Now I am changing to torr. So again I look at the chart on the left and I see that my standard pressure in torr is 760. So that value gets placed on the top of my fraction, 760 torr. To solve my problem, I'm going to take 105 times 760 divided by 101.3, and I get a value of 788 torr. Please take a minute to do the conversion from 560 millimeters of mercury to atmospheres. Make sure you show this problem in your notes that you submit to Mrs. Benke. Also, when completing gas law problems, we need to make sure that our volumes are in the same unit. Most often, this will require a conversion between milliliters and liters. Our conversion factor here is 1,000 milliliters equals 1 liter. Let's look at how these conversion problems work. Like with pressure, you take your given value, 5.2 liters, and you're going to place it over 1. Now, because I want liters to cancel, I'm going to write liters on the bottom of my next fraction. And when I look at my conversion factor, I see that the number that goes with liters is 1. So I'm going to write 1 liter on the bottom and 1,000 milliliters on the top. 5.2 times 1,000 divided by 1 is going to be 5,200 milliliters. Solve the other conversion problem. Convert from 7,530 milliliters to liters. Show your work and your answer in the notes that you submit to Mrs. Benke. This is Mrs. Benke. I want to thank you for joining me for this screencast on Boyle's law. As you should have noticed from the lab today, our variables in Boyle's law are pressure and volume. What you may not have noticed is what remains constant in Boyle's law, which is temperature and the amount of gas. The relationship is direct, and we know this because as one variable increases, the other variable decreases. So as pressure increased, volume decreased, and if pressure decreased, the volume increased, and we see that here in our graph, which should look similar to the graph that you had from the lab today. The equation for Boyle's law is P1 times V1 equals P2 times V2. When you solve a problem for Boyle's law, you need to make sure that your pressures are in the same units. Those units can be atmospheres, kilopascals, millimeters of mercury, torr, or psi. Likewise, your volumes must also be in the same unit. Usually, that is either milliliters or liters. Let's take a look at some simulations using Boyle's law.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Let's take a look at how to solve a Boyle's Law problem. A sample of gas occupies 12.3 liters of space at a pressure of 40 millimeters of mercury. What volume will the gas occupy at a pressure of 60 millimeters of mercury? When solving a gas law problem, the first step you want to take is to list the variables that are included in the word problem. In this problem, P1 is 40 millimeters of mercury, V1 is 12.3 liters, P2 is 60 millimeters of mercury, and V2 is X. To solve the problem, we're going to plug these variables into our equation for Boyle's law. Remember, P1 times V1 equals P2 times V2. 40 millimeters of mercury times 12.3 liters equals 60 millimeters of mercury times X. To solve for X, we need to divide both sides of the equation by 60 millimeters of mercury. 40 millimeters of mercury times 12.3 liters divided by 60 millimeters of mercury equals X, and X equals 8.2 liters. Add this practice problem to your notes. A gas occupies 25.3 milliliters at a pressure of 790.5 millimeters of mercury. Determine the volume if the pressure is reduced to 0.804 atmospheres. Remember that you can submit your notes as either a paper copy or on Schoology, but please make sure you have all practice problems completed in your notes in order to receive full credit for this assignment.